In this video, we're going to go over some functional groups that you should probably know for the rest of organic chemistry, because their names are going to be thrown around a lot, and just by knowing the name and the definition of each functional group, it's going to help you tremendously. So we're going to start out with some easy ones that you probably know, and then we're going to get into more specific ones that will still be used just as much as these easy ones. So alkanes, that is going to be a carbon single bond chain, and the name will end in ane, and you probably know that by now. And if it's strictly just an alkane with only carbon and hydrogen, it will follow the formula of CnH2n plus 2, where n equals the number of carbons. So if we draw a line drawing with 6 carbons, no big deal, we get something that looks like this, and we can call that hexane. Okay, now alkenes are going to have some sort of double bond. So so if it's just one alkene, where one double bond, we'll get this formula. This in A is specifically called benzene, and it's very common in organic chemistry. And we can have the double bonds alternating every other carbon, and that's how it's all commonly shown. But this is also benzene, how some people draw it. So if you want to draw it with the circle in the middle, no big deal. And of course, alkenes are going to end in the suffix ene, or ene. So if we get something that looks like this, this would be 3-hexene. Okay, alkynes. Alkynes is going to be a carbon chain that has at least one carbon-carbon triple bond, and they're going to end in yne, or ine. We're going to get the generic formula. If it only has one triple bond and all the rest are single bonds, we'll get the generic formula CnH2n minus 2. Okay, so we get something, we might get hexane, and then if we add a triple bond, this could be called 1-hexine. Okay, and I'm not worried about those so much. Most people get those down, no problem. Now, we have different degrees of alcohols and thiols in different functional groups, and this is where it can get very overwhelming and confusing at first, but if you stick with it, you will get this down. So, first of all, if we have some big carbon compound and we have an R group, an R group means that the compound continues. So instead of that being an R, it keeps going, but it's so big that it's just some sort of carbon chain, and it's not important for what we're talking about, so we call it an R group. So the characteristic of an alcohol is that some sort of carbon chain that we'll call just an R group has an OH bonded to it. And so this is going to be, by definition, a carbon chain that has an OH group branching off of the carbon chain. Okay, and if we draw 6, 1, 2, 3, 4, 5, 6, we could have an OH group like so. Now, there's different levels of alcohols. Now, oxygen always forms 2 bonds here if we're going to have an alcohol group. So a primary alcohol is going to be, we're going to look from the perspective the carbon bonded to the OH group. Okay, so that's how we want to look at this. We want to look at it from the perspective of the carbon bonded to the OH group. Okay, so this would be a primary carbon, or excuse me, a primary alcohol, because the carbon that's bonded to the OH group is only bonded to one other carbon. Now, so what would, and that's why it has 1 degree. That would be what we call primary. If we look at the same thing and we want to make it secondary, we look at this carbon, what we need is just another carbon bonded there. So this would be a secondary alcohol because this is bonded to 2 other carbons. And to make this tertiary, this carbon is bonded to 3 other carbons. Okay, so that's where that comes from. Now, I'm going to copy this entire thing because what's nice is that the prefix thio means sulfur. So this is going to be the exact same thing, except instead of oxygen, sulfur will bond in the same manner. So, a carbon chain that has an SH group branching off of the carbon chain. So instead of OH, it'll be SH. And it will still have the same rules for primary, secondary, and tertiary. This is a secondary alcohol and a secondary thiol because if I look at the carbon that it's bonded to, that carbon is bonded to 2 other carbons, okay? So that's how it gets the classification as secondary. And thiols are going to be very smelly in real life. Okay, ethers. Ethers are commonly anesthetics, and this is going to be an oxygen sandwiched between 2 carbons. And so I'm going to say some R group, some carbon group, oxygen, and then some R group. Okay, so we might get something like this with 6 carbons. Okay, an amine group is going to be some R group with an NH, and the H might be there or it might not be, we'll see, but it's going to be an NH group bonded off of a carbon chain. So we could get something like this, and what we want to remember is that nitrogen is going to form 3 bonds, so if I'm looking at this N right here, it only has 1 bond, so I'm going to need 2 H's in a lone pair. But if we change that and let's say the nitrogen had another carbon coming off of it, we would only need 1 H to satisfy that 3 bonds. So that's how this primary, secondary, or tertiary is going to work. We have something that looks like this. This is going to be primary because the nitrogen is bonded to 1 other carbon. If we wanted to make it secondary, we make it NH and then we put another carbon there. And this is secondary because it's bonded or connected to 2 carbons. And if it were tertiary, this is going to have no H on N, and that makes sense to me because if we already have 3 carbon groups on it, we don't need an H to get that 3rd bond. So this is bonded to 3 carbons. Okay, so let's get on to our last page, and this is probably the most complicated page. I'm going to do all of these, and you probably just need to study them and write them out. When I was learning organic chemistry, I had to write these out maybe 10 times in a row for each of them to sort of get them in my head. I would use Quizlet. I would use all sorts of flashcards, whatever resources work for you, but chances are it's going to take a little bit of work to get the differences between all of these down. So an aldehyde is an oxygen double bonded to a carbon in the, or at the end, to a carbon at the end of a carbon chain. Whereas a ketone is going to be the same exact thing, and so we'll see, I know they're not right next to each other, and I apologize for that, but an oxygen double bonded to a carbon in the middle of a chain. So we have carbon double bonded to oxygen. For a ketone, we're going to have two R groups, one on each side. For an aldehyde, we'll have an R group on one side, but at the end of the chain, we'll just have to have a hydrogen because it ends. So we get something that looks like this, or we might get something that looks like this, because technically that H does not need to be drawn there because it's attached to a carbon. Okay, so that's the difference between aldehyde and ketone. I would link those together. Now, an ester and a carboxylic acid are going to be very similar in their definitions as well. So an ester is going to be a carbon that is double bonded to an oxygen and single bonded to another oxygen. And it's going to be in the middle of a carbon chain. Now, the same definition, I'm going to alter it when I get to carboxylic acid here. So it's going to be a carbon that is double bonded to an oxygen and single bonded not just to an O, but single bonded to an alcohol group. Which is an OH group. And by definition, this is going to force it to be at the end of a carbon chain. So we're going to get RCO double bonded, and then that R is going to keep going because this is in the middle of a chain for an ester, where for carboxylic acid, we'll get an OH because it'll be at the end. So we might get something like this. 1, 2, 3, 4, so 5, 6 carbons, where 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. We might get something like this for a carboxylic acid to be at the end of the carbon chain. Now, we're going to have amides, and an amide is going to be a carbon that is double bonded to an oxygen and single bonded to an amine group. And this can be in the middle of the chain, and that would be called an internal amide, or it can be at the end of the chain. And that would be called a terminal amide. So we might get something like this, RC and then NH2. This would be a terminal. Or we could get RC in H and then another R. And this would be an internal. So, whatever you want to draw here in H2, And if you've taken a biology class, an amide is going to come up with peptide bonds with proteins.